Here is a problem. We are given a block diagram with three transfer functions, g1, g2, and g3. We need to find the overall transfer function g of s, which is y of s divided by u of s. Let me describe the diagram. The input u enters a summing junction with negative feedback. From there, the signal goes through g1. After g1, there is a second summing junction, also with negative feedback. From the second junction, the signal goes through g2, and the output is y. Now the feedback paths. The inner loop takes y, passes it through g3, and feeds it back to the second summing junction with a minus sign. The outer loop takes y directly and feeds it back to the first summing junction, also with a minus sign. So we have two nested loops. Our task: find the equivalent transfer function g of s from u to y. Before we start, let us recall two block diagram rules. Rule 1. Series connection. Two blocks in a row multiply. g1 followed by g2 gives g1 times g2. Rule 2. Negative feedback. A forward path g with feedback h gives g over 1 plus g times h. For unity feedback, h equals 1, so it becomes g over 1 plus g. We will apply the feedback rule twice, once for the inner loop and once for the outer loop. That is all we need. Step 1. Close the inner loop. Look at the inner loop. The forward path is g2, the feedback path is g3, both with a negative sign. Using the feedback rule, the closed loop transfer function is the forward path divided by 1 plus forward times feedback. That gives us g2 over 1 plus g2 times g3. After this step, the inner loop is replaced by a single block, g2 over 1 plus g2 g3. Now the diagram is simpler. U enters a summing junction with negative unity feedback, then goes through G1, then through the inner closed loop block G2 over 1 plus G2 G3, and the output is Y. Step 2. Combine and close the outer loop. First, G1 and the inner closed loop block are in series. Using the series rule, we multiply them. G1 times G2 over 1 plus G2 G3. That gives G1 G2 over 1 plus G2 G3. Now we have a single forward path with unity negative feedback from Y to the input. Applying the feedback rule one more time, the overall transfer function is the forward path divided by 1 plus the forward path. The numerator is G1 G2 over 1 plus G2 G3. The denominator is 1 plus g1 g2 over 1 plus g2 g3. To simplify, multiply top and bottom by 1 plus g2 g3. The numerator becomes g1 g2. The denominator becomes 1 plus g2 g3 plus g1 g2. Here is the final answer. G of s equals g1 g2 divided by 1 plus g2 g3 plus g1 g2. We can also factor the denominator as 1 plus g2 times the quantity g1 plus g3. Let us verify by tracing the signal. From u, the signal goes through g1, then through g2, giving g1 g2 in the forward path. The inner loop gain is g2 g3. The outer loop gain is g1 g2. Both are negative feedback. The denominator should be 1 plus all loop gains, 1 plus G2 G3 plus G1 G2. That matches. Let us recap. We started with a block diagram containing two nested feedback loops. In 2 steps, we found the overall transfer function. Step 1. We closed the inner loop, G2 with G3 feedback, to get G2 over 1 plus G2 G3. Step 2. We combined G1 in series with the inner closed loop, then closed the outer unity feedback loop. Final result: G of s equals G1 G2 over 1 plus G2 G3 plus G1 G2. 2 rules, 2 steps, done.